Talk about absolute value inequalities. Few things to remember. Remember, absolute values equations result in two answers. So absolute value inequalities are going to result with two inequalities. Remember that there are two different types of inequalities if I have more than one. Remember that there are and inequalities. X is greater than 2 and x is less than 5 would result in the graph greater than 2 and less than 5. I'm looking at all of the numbers in between. Remember or inequalities. If I have x is greater than 2 or x is less than -5, I would have the number line -5 and 2 greater than. In order to be a solution, it just has to be a solution on one of these lines. So, just as a reminder, let's talk about absolute value inequalities. To get started, I want you to think about what an absolute value means. An absolute value means the distance from 0. So what this statement right here is saying is the distance x is away from 0 has to be less than 5 spaces. So think of numbers that are less than 5 spaces away from 0. Here's 0. What numbers are 5 spaces away? That's only 1 space. -2 is 2 spaces, and so on. So if I'm thinking about those numbers, or if I'm plugging them in, I know the absolute value of -2 is 2, and that certainly is less than 5, so it's a solution. Okay, 1, and we decided 2 is a solution. Now, everything that is a solution has to be 5 spaces away from 0 at most. So we have these endpoints, and the solutions include everything in between. So this is an and inequality because I have an interval from -5 to 5 that has to be true for two different inequalities. If I'm looking at -5, x has to be greater than -5, and x has to be less than +5. Remember to write compound inequalities. There are two different ways. Okay, I can write out the word and, or I can simplify it. I'm going to use x only once. Remember, the smaller number goes on the left, the larger number goes on the right. And I'm going to make sure that these statements stay true. X is less than 5, and x is greater than -5. Now, one thing that I want you to notice about my answer is the following. Remember, with absolute value equations, I could write two different equations. If I have two inequalities, I can write two different inequalities. X is less than 5, and x is, remember with absolute value, you change it to a negative. Here's the difference from an equation, though. If it's negative, if I'm multiplying by a negative on one side, I have to flip my sign. So notice less than here, greater than here. All right, let's go ahead and look at my second type of inequality. The absolute value of x is greater than or equal to 3. So I'm looking for numbers that are 3 spaces away from 0 or greater. So 3 is 3 spaces away from 0. -3 is 3 spaces away from 0. Anything above 3 is more, and anything below -3 is more spaces. So if you notice, this is an or inequality. X is greater than 3. Notice that matches this up here. X is greater than or equal to, 3. Or x is less than or equal to -3. Notice I changed that 3 to a negative, and I flipped my sign from greater than to less than. Now, there is no shortcut way to writing an or inequality. You just have to leave it like this and be sure to write the word or. So this would be my inequality. So some rules to make sure you write down in your notes are the following. If I ever have anything that is absolute value is less than or equal to some variation of less than, it is always going to be an and inequality every time. The alligator mouth is facing away from my absolute value sign. On the other hand, if my alligator mouth is greater than facing towards my absolute value sign, it is automatically an or inequality. So let's go ahead and look, before we look at an example, let's talk about one more step that I need to make sure I include. I'm going to change colors. This looks like a 21. It's actually an absolute value sign. Okay, step number 1 on every single problem, isolate the absolute value. It is the case for absolute value equations, and it's the case for absolute value inequalities. Here's my absolute value right here. Here's my inequality sign, and there is a -9 on that same side of my inequality as my absolute value. I need to get rid of that first by adding 9. Add 9 to both sides. So what's left is the absolute value of 4x plus 2 is greater than or equal to 15. And I would write my inequalities from here. Notice that this is an or inequality. So just to get practice writing this, how would I write my two inequalities? In order to drop those inequality signs, those absolute value signs, I have 4x plus 2 is greater than or equal to 15, or 4x plus 2 is less than, notice I'm flipping my sign, less than or equal to -15. So let's actually practice an example. So absolute value of 10x minus 12 is less than or equal to 8. So first off, I look to see if I need to, number 1, I need to isolate. Do I need to complete that step? No. This absolute value sign is the only thing on this left side of my less than or equal to sign. So I'm going to skip this step. Step number 2, I'm going to write two inequalities. So here are my two inequalities. 10x minus 12 is less than or equal to 8. Okay. As part of that write two inequalities, is it an and or is it an or? Look at this sign right here. It starts with the small side, so less than. So this is an and inequality. I'm going to write my second inequality, 10x minus 12. Notice these are exactly the same. Greater than or equal to. I flip the sign and I change it to a -8. Now, one last reminder, remember that you don't have to write and inequalities with the word and. I can simplify it. 10x minus 12 is what has my variable, so it goes in the center. Is less than or equal to 8, and I can reuse 10x minus 12 for this inequality is greater than or equal to -8. I personally like to write it this way. It involves a lot less writing. And now I solve. If I add 12 to get rid of that, I add 12 to all sides. That results in 4 is less than or equal to 10x is less than or equal to 20 divided by 10. And that results in 2/5 is less than or equal to x is less than or equal to 2. And if I graph that on my number line, 0, 1, 2, this is an and inequality, so we're looking at an interval from 2/5, which is right around here, to 2 are my solutions. Now let's look at this next example. Step number 1, isolate. Is there any isolating to do? Here's my absolute value. There is nothing on that same side. So I'm going to skip. I get to skip this step. Now I'm going to write my two inequalities. So step number 2 gives me 3x minus 4 is greater than or equal to 11. Look at this inequality. It says greater than. So or 3x minus 4, reverse the sign, negative 11. And I'm going to solve. Plus 4, 3x is greater than or equal to 15, divided by 3, x is greater than or equal to 5. Plus 4, 3x is less than or equal to negative 7, divided by 3, x is less than or equal to 2.3 repeating. Negative 2.3 repeating. Make sure to bring the word or down into your answer. This is an or inequality. Final answer. If I go to graph it, be sure, here's negative 2. Negative 2 and 1/3 is just on this side. Less than 5, greater than 5. It's an or inequality, so notice I've got two endpoints and they are going in two different directions. Now we're going to look at one more example. When we solve an absolute value, remember that the first step is to isolate. I do not get to skip this step this time because I have -1 and 2 that I need to get rid of. When something is being subtracted, we add to get rid of it. That results in the following. Changing color. 2, absolute value of 3x minus 1 is less than or equal to 8. Still need to make sure it's isolated. This 2 is being multiplied to the 3x minus 1. Do not distribute. You cannot put numbers into an absolute value. So I need to remove it by dividing. I have the absolute value of 3x minus 1 is less than or equal to 4. Now that the isolating step is complete, step number 2, write two inequalities. So let's write them. 3x minus 1 is less than or equal to 4. And 3x minus 1 is greater than or equal to negative 4. Personally, Miss Johnson likes to write it as one inequality. And if you would like to as well, you're welcome to. Is less than or equal to 4 and greater than or equal to negative 4. So greater than or equal to negative 4. Plus 1 to all sides. Negative 3 is less than or equal to 3x is less than or equal to 5. Divided by 3 on all sides. Negative 1 is less than or equal to x is less than or equal to 1 and 2/3. So that is 1.6 repeating. So on my number line, here's negative 1, 0, 1. Okay, 1.6 is about right here. Negative 1, and this is an interval in between, so I'm going to connect my dots. Please reach out to your teacher if you have any questions.